Hello everyone. In this video we're going to find the exact value of this expression without using a calculator. Uh, First we need to remember that when we see an expression like inverse tangent of negative 15 over 8, we're looking for some angle between negative pi over 2 and pi over 2 whose tangent is negative 15 over 8. So this is just some angle, and so is this. So what we're going to do is give them a name, and that's what we do when we have these compositions of functions of this type, especially when inverse tangents are involved. So let's go ahead and do so. So we'll go ahead and let alpha be the inverse tangent of negative 15 over 8, and since we have another one, we'll go ahead and call it beta. That's just another angle too, so we'll call that the inverse tangent of 4/3. Now we know that if alpha is the inverse tangent of negative 15 over 8, that means the tangent of alpha must be negative 15 over 8. And if beta is the inverse tangent of 4/3, that means the tangent of beta should be 4/3. So now we're going to construct triangles to try to help us find the values that we need. So for we know that if tangent is negative, for inverse tangent we look between negative pi over 2 and pi over 2. So we're looking for some angle in the fourth quadrant, and we're going to set up alpha so that the side opposite over hypotenuse will give us negative 15. I'm sorry, the side opposite over adjacent. So we know that it's going to be the negative side will be the y value. So let's make it a little bit more likely, because that side needs to be longer, so it'll be more maybe like this. All right, so this is alpha. We're gonna have negative 15 here, and for the adjacent side, remember tangent is opposite over adjacent, so we're setting it up so 8 will be here. And for the other one, beta, that one is a positive tangent, so it'll be in the first quadrant, and we would like the opposite over adjacent to be 4/3. So in both cases, we're going to go ahead and find the relevant R value. We notice that for both of them, they're actually special triplets, because this is the 8, 15, 17 Pythagorean triple, and this is the 3, 4, 5. But if you don't see that, you can just set up the Pythagorean equation for it. So we get 8 squared. Remember, for the calculation of R, we don't need to worry about negatives. First of all, it's going to get squared, and secondly, we're just dealing with lengths. Remember, R is always a positive value. It's a distance from the origin to that terminal point. So 8 squared plus 15 squared equals R squared, so we get 64 plus 225 equals R squared, so we get R squared equals 289, and that gives us R equals 17. Again, if you know the 8, 15, 17 triple, you could have done that instantly. There's also 3, 4, 5. By the way, any multiple of these will be a Pythagorean triple as well. For example, if you double all of these, 6, 8, 10, that will be a Pythagorean triple as well. We also have 7, 24, 25. These are just some of the more popular ones. All right, so for the other one, we have 3 squared plus 4 squared equals r squared, so 9 plus 16 equals r squared, so 25 equals r squared, so r equals 5. Now, if we go back to our original problem, notice that based on what we called inverse tangent of -15/8 and the inverse tangent of 4/3, we can just write this as the cosine of alpha plus beta, right? Remember, this is alpha and this is beta. So now we're going to have to apply the sum identity for cosine, which as we know is cosine alpha cosine beta minus sine alpha sine beta. So we go ahead and remember beta is right there and alpha is right here. So you can see that the cosine of alpha, cosine is adjacent over hypotenuse, and we know that this hypotenuse here is 17. So we're going to get 8/17. If you want to compute those and write those here, you can. Notice cosine of alpha is 8/17. Sine of alpha is going to be opposite over hypotenuse, so -15/17. For beta, notice that the cosine of beta is going to be adjacent over hypotenuse, so 3/5. And the sine of beta is going to be opposite over hypotenuse, so 4/5. So now we just substitute. So for cosine of beta, we just found it, it's 3/5 minus sine of alpha, which is -15/17 times sine of beta, which we just found to be 4/5. So we end up with 24/85. Notice that this negative times that negative is going to turn this product into a positive product, so we get plus 60/85. Now we simply combine those. They have the same denominator, those fractions, so it's very easy. So it's going to be 84/85. So that's how you do these compositions of trigonometric functions. And that should do it for this video. So stay safe till our next video.